students, welcome back to OrganiChemVerse. In this video, I'm going to solve a question based on tosylchloride. Many of my students have asked me to solve a question based on tosylchloride. That's why I have picked up this specific question. First, what does tosylchloride refers to? It is a reagent used in organic chemistry to convert alcohols to tosylates. Then, what is the structure of tosylchloride? Very easy to remember. The T refers to toluene, that is methyl benzene. The S refers to the sulphonyl, and the chlorine is directly attached to it. That's why we call this as toluene sulphonyl chloride. What is the use of this tosylchloride? It is used to react it with an alcohol, then it will undergo substitution reaction and it will form a tosylate. How to write the structure of tosylate? So till here it's same like in alcohol, and this part you can simply write this as Ts like this. And this tosylate will make this carbon oxygen bond weak and this is ready to leave. That means what? It is making this hydroxyl group from the alcohol to leave the molecule as a better leaving group. That is the whole function of the tosyl chloride. Now, for the given reaction, how to write the tosylate? How to write the tosylate? Very easy. Just follow what I have done here. So this is the lactone as it is, a cyclic ester. And what about here? This stereochemistry will not change. It is below the plane, so it will remain below the plane. So we have oxygen and the tosylate. So how to write the tosylate? You can write like this. So this is attached to benzene and then methyl. But instead of writing like this, the simplest way to write this is OTS refers to the tosylate, and the rest of the lactone is as it is. So this is the first step happening here. The oxygen will attack the tosyl and the chlorine will leave. So you will get this product. Now, what should happen? It is treated with potassium carbonate in methanol. So since this is an ester, since we have methanol, it will undergo esterification again. So we call this as cross-esterification. You have an ester, you are preparing one more ester from it. So we call this as cross-esterification. How does that happen? So you can see here, the oxygen will attack here. This bond will open up. At the same time, since we have a good leaving group here, right, it will immediately attack this carbon and it will leave the molecule. So this is happening in one step. So it's a concerted mechanism. So how do you write the product? Very easy. You just write this carbon oxygen as it is. This is the ester, methyl ester, right? So OMe, you can write that. You don't have to write the detailed mechanism of removing this hydrogen, etc. So now what is happening? You can see this is where there is a cyclic product form. It's better to write the carbon here, and then this is attached to the oxygen, which is in turn attached to this carbon, and there will be two hydrogens. So you can write that. If you want, you can just simply use a dot here showing that there is a carbon like this. And this is what? This is a cyclic ether, nothing but this is the epoxide. And this is the ester. And where do we have this? We have it in option D. So students, I'm going to give you one more alternative method to solve this question, which is much easier and quicker. Say here in option B and C, they have given aromatic. So we don't get aromatic rings from the aliphatic rings just by treating with the base. It's not that easy. Therefore, you can eliminate option B and C. Now it's between A and D. What is the difference between these two molecules? This is an open chain from what we had earlier, and it is still remaining as a cyclized. And you can see that this is undergoing oxidation. So here we are not using any oxidizing agent. So this is also not possible. So what is the possible product form here? It's an epoxide. And how did we do that? By making this hydroxyl a better leaving group. Because it is a better leaving group, this ring will open up and it is going to attack this carbon, so that we are going to get a cyclic ether, nothing but epoxide. If you have come across any such doubts with respect to tosylchloride, you can ask them in the comment section. I'm going to help you with that. And don't forget to solve the question given at the end of this video. Thank you for watching this video. Until next time.